What up, geometry students? We are using the Pythagorean theorem in this lesson. We're finding missing lengths of right triangles, remembering that a sum of the squares of the legs equals the square of the hypotenuse. So make sure you identify what is the leg and what is the hypotenuse. The hypotenuse is always opposite the right angle. The right angle will be the largest side, so the hypotenuse, the right angle is the largest angle. The other two angles can't be 90 or above, so that means the hypotenuse will always be opposite the largest angle. And we'll just make sure, like for the first situation with the legs of 2 and 3, that we keep a squared plus b squared equals c squared. We're talking about areas here. We're using areas to find a length. And we use a square root of 13. We look to simplify it. Think about large perfect squares that could divide into numbers, and I don't have any of those, so my final answer is that C is root 13. The second triangle, we do see that the hypotenuse is 3, which means we need to find a leg, so either an A or a B. Doesn't matter if you list it as A or B, this missing leg, as long as you know that it is a leg and not the hypotenuse. So after solving for either your A or B, you get that value squared equals 8. And after square rooting to find the length, we have the square root of 8, which we write as root 4 root 2, or the simplified 2 root 2 is our missing length. In the third triangle, we have the hypotenuse of 4. We have a leg of 2. So again, you're trying to find a missing leg. Doesn't matter if it's A or B. A squared plus B squared equals C squared. A squared plus 2 squared equals 4 squared, or 2 squared plus B squared equals 4 squared. That means we'll have A squared equal to 12. Square rooting to find A or B. The leg, missing leg, will be root 12, which is root 4 root 3, or 2 root 3. Great. Find the missing lengths of the right triangles that have the following characteristics. This is question number 2. One leg is twice the size of the other leg. And the hypotenuse is 10. Okay, so I'm going to draw a right triangle. And I know that the hypotenuse of this right triangle is 10. I'm going to visualize a right triangle. I have one leg is twice the size of the other leg. Well, I don't know what the other leg is, so I'm going to label that as x, which means the twice x would be my other leg. So I have one leg that's x. I have the other leg that's 2x. Now here's what's really important. To find these leg lengths, we have to set up the Pythagorean theorem. And we have x squared plus 2x squared. That's 2x times 2x. Now that's important. Think about it. 2x times 2x is not going to be 2x squared. It's going to be 4x squared. So I have x squared plus 4x squared is equal to the hypotenuse squared, 10 squared, which is 100. Now, what we have on the left side are the same kind of x squareds. We have 5x squareds total, equal to 100. I can divide by 5 to get that x squared is equal to 20. And then I get square root to get x equals the square root of 20. The square root of 20 is the square root of 4 times the square root of 5, or 2 root 5. So that must be x. So if x is 2 root 5, we're going to double that. Now, what's 2 root 5 times 2? Well, multiplication says multiply these things in any order. 2 times root 5 times 2. So a lot of people think they have to distribute the 2, but think of 2 times 3 times 4. You could decide to multiply the 4 by the 2 first, and then just like multiply the 3 later. Well, that's the same thing here. I'm going to multiply the 2 by the 2 to get 4 root 5. So this is 2 root 5, one of the legs, and the other leg is 4 root 5. Cool. Question number 3. The hypotenuse is double the size of one of the legs. So one of the legs must be x. The hypotenuse must be 2x. The other leg has a length of root 18. Very interesting. Okay, if we set up the Pythagorean theorem, we have the missing leg x squared plus the other leg root 18 squared. That's root 18 times root 18. Root 18 squared, square roots, undo squares, is just 18. And then 2x times 2x or 2x squared is 4x squareds. Now, what do I do here? How do I solve x squared plus 18 equals 4x squared? I will subtract an x squared. I now have a total of 3x squareds equal to 18. I then divide by 3 to get that x squared has to equal 6. I will square root to get x has to be root 6. If x is root 6, our hypotenuse must be 2 root 6. What's up, Brammer? How's it going, bud?
Calculus from you?
No, this is geometry.
Ah.
All the calculus videos are up for your test. Are you locked in? You did some work over the weekend?
Yeah. I'll do a lot today.
Good, good.
Yeah.
Later. Question number 4. The hypotenuse is triple the size of one of the legs. So one of the legs must be x, and the hypotenuse must be 3x. The other leg is 8. All right, well, x squared plus 8 squared, which is 64, equals 3x squared. 3x times 3x is 9x squareds, giving me that 64 equals 8x squared after I subtract an x squared from both sides. And dividing by 8, isn't 8 times 8 64? It is. So x squared is 8, which means x is root 8. Root 8 is root 4 root 2. So x is 2 root 2. Multiply that by 3. 3x will equal 3 times 2 times root 2. This is just 2 times root 2, so I'm going to multiply the 3 times the 2 and leave the root 2 by itself, and I get 6 root 2. Great. All right, now for the other problems, we want to be comfortable with 2 different ways to find the answers to it. Okay? The understanding that when we are talking about the Pythagorean theorem in the coordinate plane, that we're not just talking about lengths, we're talking about x or y coordinates that can be positive or negative. So here's an example. We have the point 0, 0, and then we have the point x3, 1, 2, 3. So we can see this vertical distance must be 3. We want the 2 points that are 5 away. Well, we realize that we could have, well, 2 points is what I'm trying to lead you to, is that there's 2 possible points that are going to be 5 away. One will have an x coordinate that's positive, and one will have an x coordinate that's negative. Now, here are 2 things we could do. We could set up our triangle, find the leg length, and then just go 4 to the right and 4 to the left. Or sorry, I'm just giving you the answer. And go that amount of the leg length to the right and that amount to the left. Or we could understand the following. We have this x3, we have this point 0, 0, and we have this length 5. We can see from 0, 0 to x3, we have this vertical distance of plus 3, 3 minus 0, this horizontal distance of x. And we could set up the equation that x squared plus 3 squared has to equal 5 squared. All of a sudden, you have an equation that is solvable. X squared equals 16. We usually say x could equal just the square root of 16, and we just leave it as a positive 4. But since we're in the coordinate plane, we realize that there are 2 solutions to x squared equals 16. X could equal positive or negative 4. So that's kind of one way I want you to think about it. The other way you could do it, which I'm not going to show in class, is this is 25, this is 9, this must be 4. You could figure out that this is 4. And you could think about going to the right 4 and to the left 4 to get our 2 points, negative 4, 3, and 4, 3. Let's look at the next question. We have 2 points, root 7y, that are 4 units away from 0, 0. So root 7 is just some length here, root 7 as an x to the right. I don't know what the y is, but I do know that the hypotenuse is 4. It looks like I could go up or down some amount. You could find that amount by doing 4 squared minus root 7 squared, or I'm going to set up the idea that if I go from 0, 0 to root 7y, I have my x length and my y length. My y length is y, my x length is root 7, and I can set up this equation, y squared plus root 7 squared equals my hypotenuse 4 squared. The root 7 squared is 7, the 4 squared is 16. If I subtract 7, I get 9, which means y could equal plus or minus 3. Not just positive 3, but both positive and negative 3. Now, that's kind of the same thing as if we think about if this is 4 and this is root 7, if the hypotenuse is 4 and the horizontal length is root 7, the vertical length has to be 3, but we need to be going both in a positive 3 displacement and a negative 3 displacement to get our 2 answers. I want us to mostly be comfortable with either. Number 7. What are the 2 x coordinates that are 10 units away from negative 4, 7? So I got negative 4, 7. I'm just going to put it here. Just, you don't have to count off the boxes. Put it wherever you want. We have x1. So we have a y coordinate of 1. Yeah, so this is like tricky right here. So watch. Yeah, this is a lot trickier coming off of this. So maybe watch. We start with the point negative 4, 7 that goes to x1. And we can see that the vertical length is 6. Okay, that's actually what we want to do here, is to understand that from 7 to 1, that's a 6 difference. But from x to negative 4, that's going to be like an x minus negative 4 distance, or an x plus 4 distance. Like subtract these two numbers, and like negative 4 plus x gets us to x. That's like how we can get from negative 4 to x. Add 4 and add x. Well, you can say that this x distance squared plus this y distance squared has to equal the hypotenuse squared. This has to be 10. We realize that we could go in both directions, or when we solve this equation, we will end up with solutions in both directions. I get x plus 4 squared equals, x plus 4 squared plus 36 equals 100. X plus 4 squared equals 64. X plus 4 could equal plus or minus 8. Subtract 4 from positive 8. We get positive 4. Subtract 4 from negative 8. We get negative 12. Now, how did that go? Did you get that x could be 4 or x could be negative 12? That way. If you didn't get it that way, if you don't understand it that way, you could have said, all right, let's just use 10 and let's use 6. And let's realize that hypotenuse squared equals a squared plus b squared. A squared plus 36 equals 100. A squared equals 64. A equals 8. You could realize you could go 8 to the left and to the right of our -4. And that gives you to your -12 and your +4. It's good questions. Tricky questions. Just, you have to try. What are the 4 easiest points that are 5 units away from the point 1, -2? Okay, this is like very, very important because this goes back to day 1. That 5 units away on a coordinate plane, the easiest way to do 5 on a coordinate plane is to go up 5, down 5, right 5, and left 5. Coordinate plane is great because all of the boxes are 1s, but a diagonal is not 1. So we just have to take this point 1, -2, and just start adding 5 to the x and y coordinates, So like adding and subtracting 5 from the x and y coordinates. So if I add 5 to -2, I get 1, 3. All right, well, that's 5 away. If I subtract 5 from the y coordinates, I will get -7. Well, that is 5 away. I don't need the Pythagorean theorem to do this. Is that really 5? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Cool. And then I can add 5 to the x, and I can subtract 5 from the x. And not forgetting that horizontal and vertical distances are just easy to find. Just count. There's no y change or there's no x change. You don't need a Pythagorean theorem. It's not a diagonal, so you don't need the triangle. So I have 6, -2, 5 to the right, and I have -4, -2, which is 5 to the left. Cool. So all of these points, 1, 3, are 5 away. And you might be thinking, like, that creates a square. But what we start realizing is that the other points that are 5 away actually are not going to be on a square. Rather, and this is what we tried to get to in the notes today, when we start plotting all the points that are 5 away, we create a circle. So it turns out the Pythagorean theorem and circles go hand in hand. You don't think that triangles would lead to circles, but they do. What are the 4 easiest points to find that are 7 units away from the point 3, -2? So let's just start with 3, -2, and let's just add 7 to the x, subtract 7 from the x, add 7 to the y, subtract 7 from the y. So add 7 to the x, I get 10, -2, subtract 7 from the x, I'll get -4, -2. This is the right and the left 7. Add 7 to the y, I'll get 3, 5. Subtract 7 from the y, I'll get 3, -9. Okay, so those are 4 easy points to find, but remember we could find other points. And if we do find those other points, and this is kind of leading us to the next lesson, we see we create a circle. And we're going to look into the equations of circles next class. All right, hope you had fun. Hope you understand. If not, don't copy stuff down. Just come in for help. Entrance ticket next class. Peace!